Okay, now that we've talked about how energy is transferred in the atmosphere, we're going to talk about how that energy being transferred can create movement of air. That movement of air is what creates the different types of weather. So we are now on Learning Target 33, describe the factors that determine weather. So our essential question today is to find out what determines different types of weather. So weather is the state of the atmosphere at one point in time. It includes air pressure, wind, temperature, and the amount of moisture in the air. Remember, warm air rises. When warm air rises, this creates clouds. Clouds can then hold moisture. Now, the difference between weather and climate is the average temperature and rainfall for an area. So weather is the state of the atmosphere at one point in time. Climate takes an average of all the weather in an area over a certain amount of time to give you a general climate. For example, in Colorado, we have a general climate of dry, cold winters and dry, warm summers. Our climate is very different than the tropics, which are very wet and warm. Now, what you're going to look at right now is this is a picture of all the different climates in the world. And they have a classification system that goes with it. Tropical, dry, temperate, cold, polar. So you can see we are in the cold area. Now, in order to create weather, we have to have wind. Wind is when air moves. And it's caused by air moving from high to low pressure. So remember, we were talking about pressure is the amount of matter that's getting pulled down by the force of gravity. So air moves, wind is caused when air moves from high to low pressure. And we're going to come back to that when we get to high and low pressure a little bit later on in the notes. Now, in the atmosphere, another thing that's going to determine the type of weather we have is the amount of water in the air. And the amount of water in the air is called humidity. So if you take a look at this picture right here, okay, oh, I forgot. Relative humidity is the measure of the amount of water vapor present in the air compared to the total amount it can hold. So if you take a volume of air, it can hold only a certain amount of water vapor. And that's the relative humidity. It's the amount of water vapor, it's a percent. It's the amount of water vapor it could potentially hold and how much it is holding. Oh, this should be more, not mold. So the more humidity, the more cloud coverage we're going to have, because that means there's a lot of warm air rising, there's a lot of moisture in the air, so we're going to have a lot of cloud coverage. So if you take a look at this example, okay, the blue is the amount of water vapor that a volume of air can hold. So this volume of air can hold a lot of water vapor, but right now it's only holding 28%. So it's not very humid. This one can hold more than this volume, but it's holding 52% of the water vapor that it could hold. So it's more humid than the 28%. When you get 100% relative humidity, that means there is the most water vapor that area can hold. And that means it's going to be very cloudy. Now, the dew point is the temperature at which the air is saturated and condensation forms. So the dew point is where we have a lot of water in the air, and that water is going to start turning, and that water vapor, which is a gas, is going to start turning back into a liquid. So this is usually a colder temperature. Now, in order to understand why we have different types of weather, we have to know about the different classifications of air. So a large body of air is called an air mass. And remember, wind is the movement of air masses. When these air masses meet, this is when you get the weather that we have. So there's four major classifications for air masses. There's maritime polar, really easy way to remember. El mar in Spanish means sea. So think of maritime as forming over the ocean. If it forms over the ocean, it's always going to be wet. Okay, because water evaporating from the ocean is going to put water vapor into the air. So maritime means wet. Maritime polar, polar tells you the temperature of that air mass. So it's wet because it formed over the ocean, the air mass did. But it's polar, it's cold because it probably formed up north of the equator or very far south of the equator. If you look here, maritime polar on the Pacific coast right here, that's why the Pacific Ocean up north is very cold. Okay, it's getting that wet, cold weather. That's why their beaches are not as fun to go to. Then you've got maritime tropical. Maritime tropical, again, formed the air mass formed over the ocean. Tropical means warm, so you're going to have wet and warm air mass. Now, notice these are down south, okay, down by Mexico, the Gulf of Florida, and that's what we like to see. We like maritime tropical air masses because especially those of us who are in Colorado and it comes March and April, I know I get this way. I want to go somewhere warm where I'm going to have a nice, can go to a beach and enjoy that ocean. So we fly south during spring break and try to get to that warm air masses. Then another type of air mass is your continental polar and continental tropical. Continental polar, the continent means that the air mass formed over a continent, over land. Because it formed over land, it doesn't have as much moisture, so those air masses are dry. Again, polar still means cold. So right here you have your continental polar. Then you have your continental tropical, which is dry and warm air masses. And those are right here in the south. So air masses, based on the type of air that they contain, can cause different types of weather. Maritime polar, wet and cold, meets a dry and cold, different things can happen. Now, when these big air masses meet, we call that fronts. So when you've got maritime polar meeting a maritime tropical or a continental polar meeting a maritime tropical, when those big, large bodies of air masses meet, those are called fronts. So fronts are the boundary between two air masses where they meet. And there's different types of fronts. Okay, in your notes, you're going to want to draw these front diagrams, the weather symbols that go with each type of front, and you're going to also want to record what type of weather the front brings. If you want to use a textbook, you can find this in your Earth Science book, page 463 to 464. Okay, so the first one we're going to look at is a cold front. A cold front is when you have a cold air mass meeting a warm air mass. So it could be a continental polar meeting a continental tropical. What happens is because the cold air is denser than warm air, cold air will actually force the warm air up because cold air is going to come in and it's going to push that warm air up because cold air is more dense and warm air is less dense. When that happens, when you have warm air rising, you are going to get stormy weather. You're going to get precipitation. Whenever warm air rises, clouds are going to form, and depending on how much water vapor is in the air, that's going to determine whether there's thunderstorms or not. Now, if you have a continental polar and a continental tropical air mass meeting, remember continental air masses are dry. You might not get a lot of precipitation. But if you have the maritime polars and the maritime tropical air masses meeting, that's where you're going to get some very big thunderstorms. Okay, so cold front is usually associated with stormy weather that has thunderstorms, or if it's really cold, it could be a snowstorm. Now, the weather symbol for a cold front, and it's a really easy way for me to remember, is the triangle. I think of it as icicles, so that goes with a cold front. And these triangles point to the direction that the cold air is moving to. So right now, this cold front is moving southeast. So that's a cold front. Thunderstorms. Warm front is when a warm air mass meets a cold air mass. Now, When this happens, because again the cold air is denser and the warm air is less dense, the warm air will rise. However, there's a difference between a cold front warm air rising and a warm front. In a cold front, the warm air rises really quickly and very steeply because the cold air is the one that's moving in. So it pushes that warm air really up really fast and really steep. That's why you get those thunderstorms, because you have a lot of clouds that are getting pushed up and you're forming larger thunderstorm clouds. When a warm air meets a stationary cold air, because the cold air is really not moving, the warm air just gently rises over the cold air. It takes its time. And because it does that, you might have some rainstorms depending on whether the air mass is maritime or continental. But these rainstorms will not be thunderstorms. It'll just be a gentle rain. Now, sometimes it can rain a lot and you can get some flooding, but it's not going to create thunderstorms. The symbol for a warm front, okay, I kind of think it's a half circle. I kind of think of that as the shape of an umbrella. So when a warm front comes in, you usually need an umbrella to protect you against the rain. That's how I kind of remember it. Again, the direction of the half circle is the direction the warm front is moving. So right now it's moving northeast. And then the last two types of fronts are occluded and stationary. Okay, this one right here is your occluded front. Basically, in the occluded front, you have a cold and warm air mass meet, but neither one of them does a whole lot, and it kind of just pushes a little bit of warm air up. If that warm air mass has a lot of moisture, it'll create thunderstorms, but sometimes it doesn't. Occluded is kind of a mixture of a cold and a warm front. And the way you can tell the difference between those, or the symbol for that one, is it's the half circle, and I think this one's drawn a little bit incorrectly. Half circle and the triangles for the warm and cold are on the same side. Now, a stationary front is when you have a cold air mass and warm air mass, they meet. They're the same size, they're moving at the same velocity, so they just kind of pause, and it's kind of, they don't do a whole lot. They'll just stay over in a whole area. Now, what can happen is you can have the warm air rise in that area, and it can create thunderstorms or snowstorms that last for a long time, because basically the cold and the warm air mass are fighting to push through each other. And that's when you can have really long snowstorms or really long thunderstorms that last days instead of just one day. It can last 2 to 3 days. The symbol for a stationary front is the warm front symbol on one side, cold front symbol on the other. There's the occluded symbol. They're on the same side. That's how you tell the difference between the stationary. The stationary would have the half one on this side. So please make sure you've drawn all the different types of fronts in your notes, the weather symbols, and what type of weather they'll bring. Okay, the last thing we're going to talk about is the low and high pressure systems. Remember, at the beginning of the notes, I said wind is caused by air moving from high to low pressure. So it's kind of the same way as heat is a movement of thermal energy from high thermal energy to low thermal energy. The same thing goes with pressure. Pressure will move from high pressure to low pressure. So let's figure out what that means. Low pressure means warm air is rising. There's less air pressing on the ground because warm air is rising. That's where you get clouds and storms. So low pressure systems are commonly associated with stormy weather. I can't highlight today. High pressure systems is cold air sinking. So that makes sense. If you have cold air sinking, you're adding more matter on the surface, so that's more pressure. High pressure systems are fair weather. There's no big clouds because you don't have warm air rising. Remember, to have clouds, you have to have warm air rising. Now, wind will blow from high to low pressure. So that's how we get a movement of our air, is through the differences in pressure. Down below, just showing you what that looks like. You've got a high pressure system. You can see the wind is moving from high pressure to low pressure. Okay. High pressure is associated with fair weather. Low pressure is associated with stormy weather. Okay, so hopefully that gives you a better idea of how weather is created and what's going to determine that. So you've got to have a certain amount of humidity to create stormy weather. You've got to have air masses that meet, and based on what type of air masses they are, that's going to determine what type of front you're going to have and what type of weather it's going to bring. Pressure, how air is moving, is also going to determine what type of weather you're going to have.